Hey guys, welcome to episode number 21, Trading Signals Coding Session. Um, we are going to be trying to debug the changes we already made on um, to move the trading sessions project to iteration number 2. Iteration number 2 is about using the open storage project. Okay, the open storage is what means that we are going to store at the internet the information and send only a file key via the peer-to-peer network. So let's return to Visual Studio Code. Where we left last time was I was introducing this process next tick, but I think I'm going to remove it. What we were seeing is that the saving of the file was not executed. It was not being executed because the simulation was in a loop without any asynchronic operation, which means that this set interval every 1 second was not being fired. So I was trying to force this to run somehow more frequently, but besides the fact that it didn't work, I probably believe that it's even better if it doesn't run, because if you have a back test, you don't really need to record uh, all the candles in different files, or a file every 3-4 candles if you have several candles per second. It is enough to record one candle after the whole backtest is finished in the case of market files, and a candle or a file at every day cycle if it is a backtest or on daily files. So what I'm going to do to see this working and to be able to debug this, and what I'm going to do is I'm going to run I'm going to modify here the trading simulation so that it jumps several candles, um, because otherwise it's too slow and I don't want to waste 1 minute for that. So I'm going to add this here. If E equals 10, then E going to be 1,300, 400. We have 1,440 candles per day. We're running on candle of 1 minute, right? So with this change, I will be able to debug this easier. So let's go back here. Open storage, trading simulation, trading system. Okay, we got outgoing candles. So from here, we will be able to continue the debugging. So let's stop this and run this again. Oh, wait, okay, so what I did was here, sorry. I changed this line and I return here to be able to debug. So I'm going to make myself sure that I don't have pending changes here. Okay. So yeah, these were the latest refactorings. I will commit this so to start clear this session. I have some issue with this stuff now that I remember. For some reason it's not committing. Okay, I don't want to waste my time with this. I don't care. So let's run this again. Let's get to our workspace where we are working on this. Hold on. Let's check that this is running in a clean way. No browser here. So that we have a clean log. Okay, then we move to our workspace. Okay. So if our task is running, we just need to hit debug there. The problem, this is not running. Okay, when I put the platform down, this stopped. Okay, so we're running it again. Debug. Okay, they start trying to save, but there's nothing to save. So we let it run. And now we're going to run the bot. Okay, so we got one candle. Persist. It gets into the open storage client, but this is not going to be executed because this is in a constant loop without asynchronic calls. So it comes again, persist, comes again, and we will let it run. And see what happens when this finish. Jump from 10 to 1400. We'll accumulate some candles there. And it's about to finish. Okay. And now it saves the file. So we are good. This is going to be even faster without debugging. And it's going to be only one file, which put less stress on the storage provider. And it also puts much less stress over the peer-to-peer network because it's only going to send one signal at the end of each day or at the end of the whole backtesting. So when we're talking about live trading, what is going to happen is that at every candle, it's going to save one file. Every candle, every candle, every candle, every candle. Okay? So let's continue seeing where this takes us. My guess is that this is coming here. So now records to save 49, which means 49 candles. Okay, so now it blocked it to run again. Timestamp, file, all this stuff, we already had it. Beautiful encrypted file. Nobody can have any idea what is going on in there. File name, that took a while, the hash. File path. So this is going to continue up to here, and from there it should come on file save because this should work. Let's check it out. Okay, here it will come again, but it's not actually going to come in here because this is going to stop it. Okay, so what happened? We enter into an asynchronic operation that is the call to GitHub. So this fires again. Okay, so this is as expected. We don't need to track this anymore. Okay, GitHub saved the file. We're going to confirm here. My trading signals we have for the month 12. Today is 22, 1241, and we have the JSON file, and we have the file content. Beautiful. Nobody have any idea what is going on here, but that's our problem. So far beautiful. Now with the social trading bot ID, we will get a reference to the social trading bot. Yes, we got it. And then we return to broadcast the file key. Okay, so this is working. We return here, broadcast file key. So we have the file key, file name, password, timestamp, and storage container ID. Let's see if we have everything set up here. So we will run through this. We will sign this message. We are talking about signing only this part, the file key. Okay, it returned. Hold on, we were on outgoing candle signal. Somehow it seems that this sign operation is asynchronic. Maybe I should await this. It's probably internally asynchronic and I am not realizing that. It's not that it bothers me that goes somewhere else, but now I cannot continue my debugging clearly because this already got It's going to try to save the same records. Why? So something is strange here because I haven't cleared these records to save. Where am I supposed to clear that stuff? Record to save. Where does this come from? Persist. This general candle single map. Candle single map. Get social trading bot ID. I think that I am not resetting this guy. Yeah, there is a problem that I'm not resetting this because I'm here. Candle single map. I am recording. I got a key by bot ID and I'm recording an array of candles to save, records to save. That maybe I should refactor this into candles to save. Candles to save. Boom. To be more precise, would be candle signals to save. Okay. So I am accumulating candle signals in this array, which is inside this map. We are resetting the array if candle to signal is undefined. Candle signals to save is undefined, but we are never deleting the stuff in this array. Okay, that's one problem I forgot about. Okay, so what I need to do is that whenever, if I could save the file, okay, candle signal to save. Here I tried like a reset, but it's not correct. If I could save the file, and the execution, when I deliver What is this? Well, supposedly I'm resetting the array candles to save so they don't accumulate more. But there are several problems here. One is that while I'm saving, more stuff could get accumulated in here. So it's true that when this gets executed and while this is executing, no more candles can be added until there is an asynchronic operation in which more candles could be added, and then if I delete them, I might be deleting more candles than the ones that I saved. So but when the file is saved, okay, probably this is not deleting the array itself. So what I need to do is essentially this candle to save map I thinking at which point I should my guess is that here I should delete this entry with the whole array from there. And then save the file, and as long as this doesn't crash, Another thing that I need to delete is this guy. Once I retrieve the information of the node, I should just delete it. Otherwise, it will get stuck there forever. And then we're going to await this, because most likely these are asynchronic stuff. And I want to do my debugging on a straight line. So let's run this again with these changes. Okay, this needs to be an asynchronic function. And whoever is calling this guy doesn't need to await in this case. Okay, let's let it run. Debug. Run. Something not good. Yeah. Okay, so let's come here again. We got counters to save 49. Then we delete the content of this map, but we still have the content to save. So this runs, and we're going to save it. Okay, this is like unnecessary because it's a parameter that is going to die anyway. But let's check this out. Saved. So we get a social trading bot. We clear this map too. Okay, probably we should have gotten this up here. so that we do it before the asynchronic operation. We're going to do it now. I don't think we need this guy. And where's this guy declare? Okay, here there was a let missing. Put it more tidy. Cleaning these maps before the next async operation. Okay, so my guess is this is going to work like this. So if we continue here, okay, I got a little bit lost, so I'm going to redo it here from here. Here we go again. Debug. Run. Okay. So we got the bot and we clear the maps. We run here, save the file, and when finish, go to sign this stuff. Okay, there's a problem signing this. Web3 is not defined. Okay. So it was returning because there was an unhandled asynchronic exception inside the promise. Okay, so Web3 is not defined here, which is yes, is true. This used to be signed here, and now Web3 is not even used here. 104, yes. So I need to move this from here to here. From here to here. And from here to here. Okay, let's run this again. Maybe I'm going to do something here to wait less time. Running and running. Only 20 candles, more or less. And where is this? Okay, we know this works. But anyway, I will keep a breakpoint here. Not here, I don't care. This works. This works. Sign, and cool. So now we have the message on the way to the network start. So here we choose a network node and push the message to an array of message to be delivered. Here we said that we need a mechanism to retry sending and send messages. I have my notes about that, but not for now. We're going to iterate. Okay, we're not tracking this stuff because this was working. So I'm almost having this inside the network. We are going to get it here. Network node. We have a WebSocket interface, an HTTP interface, and incoming signals. So from here we didn't touch anything, in fact. So this should work pretty much fine, I would say. Let's just check it here. So my guess is we can let it go. Let it run. We got it on the network. We got this. Oops. Okay. And now we have more files to save. Length is 1. Because this backtest, even though if it is one day, it takes one candle from the other day. I don't know why, but this is expected. Probably someday somebody should fix that. But as of today, this is how it works. So I have this at the network. It has the signatures. So let's run this, validate signatures. Response, signal, okay. There is a problem. Signal message that not match signature message. Let's take a look at that. Signal message is this. Signature message is it looks good, but I cannot tell why this is not what is needed. So I'm going to let it run and wait for the next message. Remember, we are assigning the file key, so the signal message is going to be only this part, the file key. I would have expected this to come again to the network. Oops. But there's an error. I thought that we already solved this one. Peer-to-peer network interface maintain is not a function. Okay, we corrected here, but not there. Good. Okay, so the problem now is something we need to check out at the network. So we are going to run this again. Debug this again. Hold on. Okay. So we got the signal, we are at the network, yes. Enter into this validation. This is good, this is good, this is good, and this is good. This is the one that is not good. Sign in message is this. Why signal file key is nothing? signal. Something is not good here. Probably it's from my refactorings. Signal, signal, signal. Okay, so what is the value of this? Signal cannot be undefined, otherwise nothing would have worked here. Hmm. Okay. Signal message. Where is this signal message? Maybe because I refactor this but never stop it and run it again. There's no signal message here. I don't understand. Okay, let's do one thing. We run this again and we run this guy again. We don't need it to stop here anymore. Okay, we need to run this from here. Now that it's running fresh, we hit debug. Okay, we hit run. We are at the network. We got a signal here. We got a signal here. We still got a signal here. Signal message is this. Now it works. Now it works. It will broadcast it to clients. All good. Nothing else to do here. Okay, so we have completed the first half. We have completed the first half of the debugging. We got it to the point where we are sending the signal to through the peer-to-peer network and saving the file at GitHub. Let's check it out again. My trading signals for the month 12, day 22. This is probably the last one. Now we have several minutes because we did several tests. And if you open any of these files, you will see, okay, this is the last candle, it seems, of the last day, maybe, because it's smaller, the file. And these are the 20 candles, more or less, of signals, beautifully encrypted there. Okay, so yeah, so we are going to get this episode up to here, and on the next one we are going to do the debugging process from the peer-to-peer network towards the trading system, going all the way down into there, and hopefully make the test of running the two bots, the one producing the signal, the one consuming the signals. But in this case, we will end up seeing that one needs to run the whole day in order for the other run the whole day. But maybe we can put it to run 2 or 3 days, and we can see them how they synchronize day by day. Okay, so this is going to be all for this episode, and I'll come back in a while with the next ones. Thank you for watching. See you next time.